This lesson will introduce you to Lean principles and how they are used in the organization to improve business performance. In this lesson, you will learn about Lean, its benefits and tools, theory of constraints, and value stream map. Zara is a Spanish clothing and accessories retailer. It is the world's largest apparel retailer worth $9.4 billion. The competitors are eager to know Zara's secret. The secret of Zara is that it follows a well-executed and sustained lean business model. You may ask what lean business model they follow exactly. Zara store managers break the fashion supply chain rules by holding low stock and updating new collections twice a week at precise times. Lean customer focus is a lean principle in which the customer determines what is important in a product or service. Using this principle, store managers from 2,000 stores in 88 different countries feed the customer's buying habits into a computer at the collection counter every evening. The information is then sent to the distribution center, where it is picked up by Zara's design team. Designers then condense the information, which allows them to make improvements, reduce customer friction, make excellent fitting clothes, and identify popular selling garments and items returned from the unhappy customers. This lean business model helps Zara to lead the world's fashion market as a retailer. Are you ready to learn more about lean concepts? Under the topic Lean Concepts, you will learn about what is lean, why use lean, lean versus Six Sigma, the history of lean, the lean waste, common lean tools, and the theory of constraints. The term lean refers to creating more value to customers with fewer resources. It means reducing unwanted activities or processes that do not add value to the product or service for the customer. The lean philosophy is to provide perfect value to the customer through a perfect value creation process that has zero waste. While the ultimate goal is to achieve zero waste, you may not always get that in the first couple of tries. However, you will achieve minimum waste and continue to move towards zero waste eventually. Hence, lean is the path towards perfection. Lean is about optimizing the process from beginning to end, eliminating non-value-adding activities, NVAs, and increasing flow to ensure that parts and services are provided to customers more quickly. If quality is the word to describe Six Sigma, then speed is the word to describe lean. Let's understand the importance of lean. There are many benefits of lean, and some of them are reduced cost, reduced cycle time, more throughput, and increased productivity. Despite all of these benefits, lean is not implemented by most of the organizations because of the misconception that it is only suited in manufacturing areas. The reason for this misconception is the beginning of lean. It began and grew in popularity in the manufacturing areas, starting with Toyota. In recent years, one can notice more applications of lean in other areas, such as healthcare and the transactional space. However, the truth is that lean concepts can be applied in any business and in any process. On the next screen, let's discuss how Lean and Six Sigma combine. Lean and Six Sigma are two different principles or methodologies that combine to form and create one powerful continuous improvement methodology. They have various overlapping goals toward the improvement, with the aim of creating the most efficient system. Though the approaches are different, the methods complement each other. Lean Six Sigma takes the power and rigor of Six Sigma methodology and combines it with lean concepts, leading to faster results, better quality, and improved customer satisfaction. Let's look at the differences between Lean and Six Sigma. Lean focuses on efficiency by identifying value from the customer's point of view, removing unnecessary steps in the process, and improving process speed or velocity. On the other hand, Six Sigma focuses on effectiveness with the help of breakthrough processes, identifying root causes, and reduction in variation. Therefore, when Six Sigma is combined with Lean, it is possible to achieve business transformation. So remember, Lean is about speed with a focus on efficiency, Six Sigma is about quality with a focus on effectiveness, and Lean Six Sigma brings the best of both together. To yield a better result, first implement Lean to streamline the process. This helps to understand the chronic problems and the ways to handle them quickly. Once the problem is identified, use Six Sigma methodology to analyze the issues and provide business improvement transformation. In other words, Lean is used to reduce the waste, and Six Sigma is used to reduce the variation. So far, we have learned what Lean is, benefits of Lean, and Lean versus Six Sigma. Let's now look at Lean's journey. Lean started its journey hundreds of years ago. In the 1450s, Lean principles were present in the form of interchangeable parts, automatic assembly line, automatic defect detection, and more. In 1913, Henry Ford fully integrated the entire production process to a moving assembly line. It produced to only one specification limit. There is a famous saying for the Model T: you can have it in any color as long as it's black. This was not able to provide variety to the clients, however. In the 1930s, Toyota's Kiichiro Toyota and Taiichi Ohno met this requirement in the 1930s with the Toyota Production System, or TPS. It provided a variety of products while still improving process flow. TPS shifted the focus from individual machines and their utilization to how the product flowed through the entire process. The term Lean was coined by James P. Womack in the book The Machine That Changed the World, which spoke about the 5 major principles that Toyota implemented. In the next screen, we will look at the principles that drive Lean. There are 5 key principles in Lean. At times, they are referred as the Lean 5. They are identify value, map the value stream, create flow, enable pull, and seek perfection. Identify value. The first principle, identify value, states that it is important to first identify the end customer for a product or service. Then, know how the customer perceives the products or the service. This is important as it puts the organization in a better position to optimize the process. Map the value stream. As per the second principle, map the value stream. It is necessary to visualize the flow of the end-to-end process. The end-to-end process includes everything from acquiring the products or materials from the supplier to the final goods or services reaching the customer. This exercise allows the organization to clearly locate the waste in the process flow. Current flow. The third principle is about creating the flow in the value stream. Flow is created by minimizing the frequency of stopping and starting. This ensures that the product or service can reach the customer without any interruption. Enable pull. Responding to customer pull or enabling a pull system is the fourth principle. A pull system is one in which neither products are produced nor services rendered until customers have placed an order or provided demand. This ensures that minimal waste is created. In some scenarios, like a pharmacy, a pull system is not desirable. In a pharmacy, customers do not want to wait for a drug to be manufactured after an order is placed. In this instance, a push system may be required. In a push system, the finished goods are ready for customers to purchase. Therefore, they are made as per a forecasted demand. Seek perfection. The last Lean principle is about seeking perfection. Perfection means that we achieve the complete elimination of waste or muda, have continuous flow in the value stream, and have a pull system wherever applicable. This principle puts any Lean organization on a long but rewarding journey of continuous improvement. The end result is a value chain in which every activity adds value. Here's an example. A technology organization that wants to improve their smartwatch product line will need to identify what the customer really wants. Without knowing what the customers want and simply adding additional features, adjusting the price, or changing the marketing strategy to market a product customers don't want is not valuable. The organization would then visualize the flow of the smartwatch manufacturing process to see which activities contribute to providing the features the customers want, such as phone connectivity, and which they do not want. Then, any process elements that result in products waiting, such as batching or departmentalization, need to be addressed to create flow. This ensures that orders that took days can now be completed in a few hours. Now, smartwatch customers' demand is stabilized because customers can order what they want when needed. The lead time is greatly reduced, and product discounting campaigns are no longer needed to push product. The more pool of smartwatches from consumers means better flow is required. This means more removal of unwanted activities from processes. This means better identification of the features customers really want. These principles interact, and there is no end to the improvement effort. Everyone gets involved: subcontractors, suppliers, assemblers, distributors, and customers. Now, let's know more about the 3 M's of Lean. Lean focuses on relentlessly eliminating 3 major process issues, or the 3 M's of Lean. They are muda, mura, and muri. Muda means waste. Mura means unevenness, and muri means overburden. Unevenness and overburden are often the causes of waste experienced in the process and are as critical as muda. Muda refers to waste or any non-valuable activity in a process, such as waiting. More examples of muda waste are discussed later in this lesson. Mura, or unevenness, is caused by placing demands on the people and our processes due to fluctuations in customer demand. For example, when a process manager pushes his or her team at the end of the month to meet a monthly production target, it often leads to the production of unnecessary parts. Muri, or overburden, can be caused by not providing the right training to the teams, not having the right resources, lack of defined process, or having poor measures of performance. For example, the distribution department being held responsible for product defect rate would put unnecessary burden on the distribution team members for something they cannot control. A better metric for the distribution department could be extra time to deliver products to customers. Using Lean to improve mura, muri, and muda will lead to impactful results. Waste or muda refers to the steps or activities in any process that do not add value for the customers. A Greenbelt professional should be able to identify these waste in the processes. There are 8 types of lean waste. One can use the acronym downtime to remember them. Let's learn about these in detail. Click on each acronym to know more. D stands for defects, repair, or mistake. This refers to efforts caused by rework, scrap, and incorrect information. In manufacturing industry, a defect is referred as rework or scrap, or as poor quality material fit. In the service industry, a defect could be shipping packages to a wrong address, or even providing the wrong services to a client. In healthcare, a defect could be not ordering the correct labs, or patients receiving a misdiagnosis. O stands for overproduction. This refers to the production that is more than needed or before it is needed by the customers. In manufacturing, an example for overproduction could be producing 10 products when the customer only ordered 5, or producing large batch sizes. In service, overproduction could refer to duplication of effort. In healthcare, overproduction could be delayed discharges or unnecessary diagnosis procedures. W stands for waiting. This refers to the wasted time in waiting for the next step in a process. In manufacturing, the waiting time refers to idle time, delays, and long changeovers. In service, the waiting time could be meeting overrun and customer on hold. In healthcare, the example could be the waiting time for a lab result or patients waiting to consult the doctor. N stands for non-utilized talent. This refers to the talent who or which are not utilized in the processes. In manufacturing industry, non-utilized talent could be the unused resource. In service industry, non-utilized talent could be ambiguous roles and responsibilities or wrong resource allocation. In healthcare, non-utilized talent could be lack of sharing of ideas to improve. T is for transportation. This refers to unnecessary transportation of products. In manufacturing, the transportation of finished goods to a warehouse instead of shipping department is considered unnecessary transportation. In service, this could be unnecessary handoffs and loopbacks, or shipping hard copies that need signatures. In healthcare, this refers to moving patients from room to room and moving information by email. I stands for inventory. This refers to excessive finished or intermediate goods stored. In manufacturing, this could be buffer and safety stock inventory or material between operations. In service, this may be invoices waiting to be paid or excessive multitasking. In healthcare, this could look like overstocked consumables and supplies. M is for motion. This refers to the unnecessary movement by people to complete a task. In manufacturing, unnecessary bending and twisting by operators is considered unnecessary motion. In service, searching for data is considered unnecessary motion. In healthcare, looking for materials and equipment, or nurses walking from station to patient's room is considered unnecessary motion. E stands for excessive processing or overprocessing. This means doing more work than required by the customer. In manufacturing, handwork of polishing and deburring or adhering to unnecessarily tight tolerances is considered excessive processing. In service, excessive quality reviews and duplication entries are considered excessive processing. In healthcare, performing a surgery when a non-invasive procedure would work is considered excessive processing. Take a detailed look at the different lean tools and techniques that help in reducing the waste and improving the processes. The common lean tools and techniques are Poka-yoke, 5S, Kanban, Kaizen, Anjunka, standardized work, takt time, and JIT. Poka-yoke, or error proofing, is used to design defect prevention into the production process with the goal of achieving zero defects. An example is a car that will not lock the doors if it senses that the car keys are inside without the driver. 5S eliminates waste that results from a poorly organized work area. 5S is the organized approach to labors that ensure tools are in known locations. Kanban is a method used to regulate the flow of goods in order to eliminate waste from inventory and overproduction. An example is relying on signal cards to indicate when more materials need to be ordered. This is used to replace physical inventories. Kaizen, or continuous improvement, refers to a culture where employees work together proactively to achieve consistent incremental improvements. For example, Toyota has a Kaizen culture, and this is desired in any lean organization. Anjunka is a form of production scheduling that purposely manufactures in comparatively smaller batches. It reduces inventory and lead times of each product type or variant. For example, Zara's ability to change and update clothing styles and provide to customers quickly. Standardized work documents the procedure's best practices. Examples are procedures and job aids. Takt time refers to the pace of production in which production with customers' demands are well aligned. An example is knowing the frequency in which a product needs to be completed to meet the customer's demands and help pace production. JIT, or JIT, is a philosophy. It produces necessary units in correct quantities and required quality at the right time. It relies on lean tools like Kanban, Anjunka, standard work, and takt time. For example, Dell uses JIT principles to provide short lead times to customers. Next, let's learn about another concept, the theory of constraints. Now, the methodology that helps in lean implementation. The theory of constraints, or TOC, is a problem-solving methodology. It is used for identifying the most important limiting factor, known as the constraint, that stands in the way of achieving a goal, and then systematically improving that constraint until it is no longer the limiting factor. A process can only be as productive as its most limiting constraint. This theory of constraints focuses on achieving a central, overarching goal for an organization by focusing on the most important limiting factor. Let's understand the difference between the lean and theory of constraint methodology. The goal of theory of constraints is to increase profit by increasing throughput. Therefore, it measures throughput, inventory, and operating expense. The constraint or bottleneck is the area of focus with a 5-step approach that acts locally or on a particular process. Lean's goal is increasing profit by adding value, and this is measured by cost, lead time, and value added percentage. The focus is on waste elimination and value creation with a 5-step approach that uses global thinking to impact the entire value stream. Theory of constraint methods fit nicely into the lean thinking 5-step change framework. Between step 2, map the value stream, and step 3, create flow. Using theory of constraints can help lean change agents to improve performance in processes, specifically realizing the benefits of the ideal future value stream map. Theory of constraints can help us determine where to begin in the value stream map by focusing on the reason impacting throughput. It'll allow us to sustain momentum. The theory of constraints will allow us to sustain momentum by making improvements to processes that are awaiting technology or equipment solutions that take time to develop. It'll also help us replace traditional financial metrics with performance measures that support lean implementation. The benefits of theory of constraints are increased profit, fast improvement, improved capacity, reduced lead times, and reduced inventory. Increased profit is the primary goal of theory of constraints for most companies, while fast improvement is a result of focusing all attention on the system constraint. Improved capacity optimizes the constraint and enables more production. Reduced lead times optimize the constraint and faster product flow, and reduced inventory moves bottleneck results that leads to WIP or work in progress. Theory of constraint provides 5 focusing steps methodology to eliminate constraints. The 5 steps are identifying the goal and the current constraint to achieve the goal, exploiting the constraint to make quick improvements in throughput, subordinating to the constraint and ensuring that all other activities support the constraint need, elevating the constraint performance by considering what additional improvements can be made, and finding the next constraint since it is a continuous improvement cycle. Let's take a look at an example to understand how theory of constraint works. Kind Heart Hospital's emergency department is not able to keep up with daily demand. On average, the hospital receives 120 patients per day. Registration can process 200 patients per day. Triage can process 180 patients per day. The medical team can treat up to 90 patients per day. And the discharge unit can process 160 patients per day. How can the theory of constraints methodology be used to improve this process? From the data, it is clear the constraint is the treatment process. It has the lowest production rate. A quick improvement in the throughput can be made by introducing temporary workers to help treat the patients. To subordinate everything to the constraint, it is necessary to keep the process before and after the constraint running at a steady pace. Since the constraint is not eliminated, solutions to improve the treatment process is considered and implemented. It is important to continue the cycle and look for the next constraint. The theory of constraint method can work with lean, but is different from lean. Remember that theory of constraint is focused on throughput, while lean is focused on waste. Under this topic, value stream mapping, you will learn about what is a value stream map, value stream map elements, and value stream analysis. Value stream map, or VSM, is a type of process map. A VSM is a visualization tool to map the flow and identify all activities involved in the product or service from supplier to customer, or the value chain. It helps to identify and eliminate or reduce the non-value added activities. Value stream mapping answers questions such as, what does the current process look like? How does value flow through the process? What are the sources of the waste in the value stream? What areas of the process need the most improvement? What steps in the process add value, and what steps do not add value. Let's now find out about the types of value stream maps. An organizational activity can be classified into three types. They are value added or VA, non-value added or NVAs, and required non-value added activities or RNVAs. Value added activities add value to the process and for which customers are willing to pay. Normally, VAs represent those activities that change fit, form, or function of materials to transform them to a final product or service. An example would be an IT team completing a help desk ticket. Non-value added activities are activities which do not add value to the process and for which customers are not willing to pay. These activities do not change fit, form, or function. An example is a delay in raw material procurement. Required non-value added activities are activities required for the process but do not add any value to the customer's perceived value. An example would be quality checks and staff training. These are activities important to the business to remain in the market, but are not activities the customer is directly paying for. The objective in VSM is to classify each activity in the value chain into one of these three buckets. Then the goal is to maximize value-added activities, eliminate non-value-added activities, and reduce required non-value-added activities. When processes are first mapped, it may display only about 10% of the process is value-added. Let's look at the elements that make up a value stream map. A value stream map is made up of a standard set of symbols. These symbols are then used to visualize a process. A value stream map is made up of three sections: the top section, the middle section, and the bottom section. The top section shows the amount of information flowing in the process. The middle section displays how the materials flow. The bottom section shows lead time. Lead time is a lean metric that tells how long a customer is waiting for a product. All these elements combined help determine where one could experience the waste. In value stream analysis, the current state of the process is first mapped and then analyzed for waste opportunities. VA, NVA, and RNVAs are identified. As the process is standardized, which is the foundation of lean, and easy to remove waste is eliminated, we have what we call a stable current state. An ideal future state can then be mapped to indicate how the process should work with the elimination of all waste. The ideal future state is typically not something that can be achieved right out the gate. So intermediate or transient future state maps are created to strategically show the journey of how the process will transform into the final ideal future state over time. Each transit value stream map will provide objectives and targets to achieve in order to improve the process and bring the organization another step closer to the desired end state. With this, we have come to the end of this lesson. A few questions will. In this lesson, you have learned the following. Lean focuses on maximizing customer value while minimizing or even eliminating waste. Lean and Six Sigma are two different principles or methodologies that combine to form and create one powerful continuous improvement methodology. Principles of Lean are identify value, map the value stream, create flow, enable pool, and seek perfection. The common Lean tools and techniques are Poka-yoke, 5S, Kanban, Kaizen, JIT, Einjunka, standardized work, and takt time. The theory of constraints is a methodology for identifying the most important limiting factor that stands in the way of achieving a goal and systematically improving it. Value stream map is a visualization tool to map the flow and identify all activities involved in the value chain. This concludes Lean principles in the organization. The next lesson is Design for Six Sigma, DFSS methodologies.